of all the rational exams that show up on the exam, this is their favorite one. So this is an exam favorite. So let's see what happens in this equation. Step number one was our factoring. Well, we can't factor the top, but the bottom is the difference of squares. X minus 3, x plus 3. As a result, step number two, non-permissible values. X can't equal 3, and x can't equal negative 3. Does anything simplify here? Yes. The x plus 3 and the x plus 3 simplify. Okay? When it simplifies, write out your new equation. When writing out my new equation here, there's still going to be an x minus 3 on the bottom. Okay, number one mistake that students make is when everything cancels out on the top, somehow x minus 3 moves to the top. No, x minus 3 is in your denominator. It's still in your denominator. What do I write in my numerator if everything cancels out? A 1. So this is our new equation. What do we know about this new equation? Well, since the plus 3 canceled out, we know that we have a whole at 3, negative 3, comma, because negative 3 is the non-permissible value with x plus 3. What would be the coordinates of y with the negative 3? We plug negative 3 into our new equation, and we would get 1 over negative 6. That's our whole. The negative 3 that's still there, that non-permissible value is a vertical asymptote. So this is our first graph with a whole and a vertical asymptote. Step number 3. When looking for horizontal asymptotes and oblique asymptotes, now you look at your new equation. From now on, we never go back to the original equation because it's been simplified. We are now trying to graph y equals 1 over x minus 3. What happens when the degree is larger in your denominator? Is that an oblique asymptote or horizontal asymptote? Horizontal. So we will have a horizontal asymptote at, and whenever it's larger in your denominator, you always have a horizontal asymptote at y equals 0. Okay, so we can start off to the side. We can graph some things. We know that at 3, let's put our asymptotes in here. At x equals 3 and y equals 0 are our two asymptotes. And at negative 3, (1 over negative 6), we have a hole. So I'll just draw a hole, a circle, in my graph there. For our nice points, starting with your y-intercept. Again, we don't go back to the original equation. We go back to our simplified equation. If I plug in 0 for x, can you see that you get negative 1/3 for y? So we have the point 0, comma, negative 1/3 for our y-intercept. For our x-intercept, we go to our new equation. Remember, with a fraction, the only time a fraction is equal to 0 is if the numerator is equal to 0. But our numerator is 1. Is 1 ever equal to 0? So there are no x-intercepts. Okay? Look what happens if you would have went back to your original equation. Can you see yourself wanting to put negative 3 as an x-intercept? But negative 3 is a non-permissible, sorry, not negative 3. Yeah, negative 3. Did I do something wrong here? No, that's good. Oh, but negative 3 is our whole. So you would have had, is it a whole or is it an x-intercept? And trying to draw those both at the same time would cause you some problems. Now we have 2 points. There's that part of your graph in that section. Notice we don't have anything when x is bigger than 3. So I would plug in x equals 4. That would give me 1 over 4 minus 3, 1. So we would also have the point 4, 1, and then you have enough to do that section as well. So the exam really likes graphs with holes in it and vertical asymptotes and horizontal asymptotes. The exam, for whatever reason, does not like oblique asymptotes. Okay, you will have oblique asymptotes on your test, but I haven't seen an oblique asymptote on an exam yet. But I do see a lot of questions like this. Unfortunately, in your textbook, this is the only example. There's not one in the homework like this. So when I'll give you some more examples like this when you do your vertical activity, so you get some practice with these ones. So, no more questions for homework.